There's some harder problems I got to teach you how to do using the same law. All right, that's what we're going to do today. 2 examples, and then I'll give you some time to work on some new ones. Then we're going to start something brand new in the second half of the period, okay? Brand spanking new.
You mean like a new chapter or just?
No, same chapter, but a new topic. We're going to get away from ideal gas law and that stuff. It's still going to be on gases in the mole, but a different use for them. Something you'll be stoked about.
Oh no.
Yeah,
What?
Yeah,
You're going to be stoked.
Slow Sunday.
Because we're going to do stoichiometry next
It's
time.
my joke every
Yeah, I stole it from Marie. Full disclosure. Stole that one from Marie. But I still take credit for her expanded repertoire of bad jokes. I feel that I've contributed in some small way to that, and I am proud of that. Even though she won't give me credit.
That's wrong. Oh, hey, I brought my flash drive.
That's example 3.
Example 3.
Oh, sorry. Example tree, whatever.
I already wrote 4.
We have time.
I already wrote 4, so.
Are you ready? Oh, wow, I can't even see it on the camera. The camera is not high enough. There we go. That's better. All right. You ready? Now, this guy's a little bit more difficult. You'll see why in a minute. Okay, watch. Let's write down. We'll start out the same way we always do. We'll write down the given information. P, V, N, R, T. Okay. And we'll look for everybody up there we need to find. My pressure, what's my pressure up here? 740 torr, right? I can't use that. Remember, in the ideal gas law, I've got to convert everybody to use a constant. I got to convert everybody to atmosphere. All the pressures to atmospheres. 1 atmosphere contains 760 torr. What do you get for that?
0.975.
0.975? Okay. Shh. All right. 0.975 atmospheres. What about my volume? Can't use that either. It's 855 milliliters, right?
185.
But it's going to be 0.855 liters. Okay, not bad. Uh-oh.
There's nothing.
Yeah. We're going to skip that guy for a minute. Let's fill in the rest of this stuff. What's R? Liter atmospheres per mole Kelvin. And my temp. 98.6. No. That's my temp. What's this guy's temp? 28 degrees Celsius plus 273, which is what? 301 Kelvin. All right. So all those, nothing real surprising there, but we got a problem with N. All right. And here's the problem. I'm going to show you what basically you have to make. You're going to have to break N down. What does N stand for again? Moles. Okay. I want you to think about this. What is moles? Moles is basically, if you look at the periodic table up there, look at carbon. I have to use carbon when I talk about atomic masses. Carbon's atomic mass is 12.011 grams, right? All right. His molar mass, don't write this down. His molar mass is 12.011 grams. Now, if I have, therefore, 12.011 grams of carbon, how many moles do I have? 1. If I have 24.022 grams of carbon, how many moles do I have? 2. Okay. So, if I know the mass, and I know the molar mass, I know how many moles I have. What do I do with those two numbers?
Subtract them, divide them.
Well, I either add, subtract, divide, or multiply them. Yeah. What do I do? If I know I have 24 grams, I know the molar mass is 12, how many moles do I have?
2.
You all agree it's 2. What did I do with those two numbers? I divided them. Because that's what moles is. Moles is the mass you have divided by the molar mass of that compound. You all agree?
Yeah.
That makes sense. If I have 12 grams of carbon and its molar mass is 12, 12 divided by 12 is 1 mole, right? If I have 24 grams and its molar mass is 12, 24 divided by 12 is 2 moles. So that's the definition of moles. Why do I say that? Here's why. Because this problem doesn't ask me for moles. It asks me for molar mass, and it gives me a mass. Mass and molar mass are right there in the definition of what a mole is. A mole is the mass divided by the molar mass. Agreed?
Sure.
Yeah, so that's all I'm going to do right here. You're going to break moles down into mass over molar mass, which makes this equation doable. I can actually do it now. Let me erase this stuff over here.
2.18 Gs.
Okay, because I do know the mass is 2.18 grams, and that gives me just one unknown, the molar mass.
The X.
There you go. So, does everybody see where that came from? All I did here was I substituted into it. You've done this before in equations, where you substitute something else in for a variable of the equation. I substituted in the definition of what moles really are in here. Okay, that's what I did. And so instead of just using moles, I'm going to solve directly for molar mass, because moles is mass over molar mass. And I'm given the mass, and I can solve for that. Now, it does make for a harder problem to rearrange algebraically, because here's what the equation becomes. PV equals nRT is my equation. But we're not going to use that. You can write it down. We're going to use PV equals mass over molar mass RT, which makes it a little bit harder to do. I probably should have, I'm going to scoot that over a little bit because I'm going to run out of the board here in a second. Okay, let's try it again. Okay? Now, this one I told you, I've been trying to get across to you throughout the year, your algebra that we're doing here, how to do it. And I've taken shortcuts where possible. In this case, I'm not going to take a shortcut. I'm going to do it by the basic rules. What am I going to do if I want to get molar mass by himself? No, I am not going to divide by RT. That won't be the first thing I'm going to do, but it's the first thing you would want to do, probably. No, I got to get molar mass out of the denominator. He's down in the bottom right now. So what should I do to both sides first? Multiply both sides by molar mass. That will get him out of the denominator. All right, multiply both sides by molar mass. Okay, and so I'll get molar mass PV equals mass RT. Now I can do it. Now I can do it. This is why I told you not to do.
What?
Oh, I thought you wanted your boots.
No, I was waiting for the break.
Go away.
Yeah, you only find clubs.
All right.
Okay.
Okay, now that I've got molar mass PV equals mass RT, what am I going to do?
Okay, well, I did it exactly how I said. It still works. So.
Well, you can't just do what you say. You'd have to do another step after that. And the other step after that, I think people will get wrong. You have to do actually two more steps, because all you said was to multiply or divide by RT. Then all you'd have is mass over molar mass, PV over RT. You'd still have to get molar mass out of the denominator, or you could flip them around, and then get rid of mass. So I'm saying you still have more to do. I'm just using the basic rules. But if the first step is probably not the best idea to just get rid of RT. Best idea to get this guy in the numerator. Just saying. Now it's very easy. What do I do to both sides now? Divide by PV, right? And that will make him molar mass equals mass RT over PV. I can plug all those guys in. My mass is 2.18 grams. By the way, watch what happens when I keep my units for this. I don't have I'm running out of room on the board here, but I think I can do it. Mass R is 0.0821 liter atmospheres per mole Kelvin, and T is 301 Kelvin.
Sure it's not 401?
No, 401.
Yeah, that was a joke.
Very good. I could do that. I'll have to just 128 add to it. All right. P is yellow, but besides that, 0.975. See, I got one new one there. And V is 0.855 liters. Okay. So what does molar mass equal? Everybody plug that in because there's another case where you could very easily screw this up. There's a lot of math to do here, a lot of order of operations to worry about.
I don't make math mistakes.
Math mistake making.
See what you get for that answer. That's a lot of work on that
Mike
problem.
Knaus is the answer.
What did you get, Michael Knaus?
64 grams.
60. Well, how many significant figures we got here? 3 everywhere? Pretty much 3 everywhere. 64.6.
64.6. Well, my calculator must not be calibrated because I actually got 63.
Or 64.7, something like that. What is it?
Oh,
64.6 is it?
Yeah.
Now, yo, watch this. This is kind of cool. If you keep your units, look what happens.
Wow.
All right. What we got here? We got atmospheres and atmospheres cancel.
Grams.
We have Kelvin and Kelvin cancels. We have liters and liters cancel, but we don't have two things that cancel, and that's good because it actually makes sense. What does not cancel? Grams over moles. Let me just rephrase this.
Whoa.
Here's my rephrasing of this. What molar mass is 64.6 grams per mole. That's how many grams there are in a mole. Kind of like the molar mass of carbon is 12.011, which means there are 12.011 grams per mole. In this case, the compound we were finding here, his molar mass was 64.6. Now, I don't see an element up there with 64.6. Okay? What does that probably mean he was?
Compound.
A compound. Yeah, he probably was a couple of elements together. Nitrogen and sulfur or hydrogen or whatever, and any gas that could have had a molar mass of that. Okay? All right. But that's a lot of work. You notice how that's a much harder problem than the ones we've been doing.
Are we gonna like take the molar mass and find the compounds inside?
Actually, you can. We have one more lab to do, but it's not going to be that one. It's going to be a lab on stoichiometry of gases. All right, let's do one more. Last one for today, and then you'll have some problems to work on.
Like a worksheet or the homework problem?
Homework problems. Next chapter, next class, I should say. Next, we're going to be doing something new, but I don't have a worksheet for just these problems. We've done, a couple of worksheets already in the lab, so I think we're pretty good at these. These are just the harder ones.
This is example 4.
Yeah, right. All my examples apparently are off by 1 here for some reason. This should be example 4.
So, we'll have to look at all of this.
All right. Yeah, I threw this one at you a little bit easier to try to, so I don't have to waste as much time doing it. Okay, all of these guys are in the right units, I believe, so it won't be as hard to get it going. PV equals nRT, P, V, N, R, and T.
CL2.
Your pressure, you look him up, 3.50 atmospheres. Your volume, you look him up, 10.0 liter. We're going to leave him go for a second. Moles. Go down to R, 0.0821 liter atmosphere per mole Kelvin. And your temperature is 300 Kelvin. Now I want to show you something about this guy. You could do this one as mass over molar mass again, right? Or you could just solve for moles. Because what would happen if I solved for moles and got the answer for moles? What does the question want? Mass. What could I do when I get that answer then after I'm done? Convert it. So either way you want to do it. I think most of us probably would rather do it as this and not to have to use the uglier equation. So we'll do it as this. Okay, PV equals nRT. What do I got to do to get N by himself? Divide by RT. I could, like I said, have done it all at once, but I think most people would rather have an easier equation to rearrange. So N equals PV over RT. So it equals 3.50 atmospheres times the volume, which is 10.0 liters, over R times T, which is 300. All right, let's see what we get for N then. What does N end up equaling here?
1.42.
1.42, everybody else get that?
Yeah.
Anybody else get that?
Yeah.
1.42 moles. And all you got to do now, if you know it's 1.42, but y'all get that? If you didn't get that, did you divide it correctly? Was it a different problem? Or is it not right?
It's right.
It's possible. No, it's right? Okay. Looks like most people got that. All right. So now I'm not quite done yet. I got 1.42 moles.
101 grams.
I now have to convert it to grams. Moles in the bottom,
Thank you.
grams on the top. 1 mole contains how many grams of chlorine? I even wrote it out for you guys because Hannah and her sisters and many other people have been forgetting about diatomic elements. Chlorine, fluorine, oxygen, nitrogen, those guys, those 7, have to multiply by 2 because they have 2 per molecule. So that's not 35.453, it's 70.906. And when you do that, what do you get?
101.
101 grams. Is that right?
Yeah, baby.
Looks good to me. All right, you only have a couple of problems for homework. They are ABCs to them, and it's thrown in there a density problem in each one of them. That's right.
Try to trick us.
Mm-hmm.